Hello everyone, and welcome back to the second portion of our lecture video on Ogre's scene graph. And as I mentioned in the previous video, we are going to start looking at establishing and building our scene graph a little bit more cleverly. So let's go over and see what we did previously. And what we're going to do is we are going to go ahead and create our entities, which are basically our meshes, in one round, and then we're going to build our nodes, and then we're going to attach the entities to the nodes. So basically, if you remember, the tasks to add something in your Ogre scene was to create a scene node, to hold it, then add the node that you created as a child of a node that you wanted to be parented to, and then create the entity for it. And then once the entity is created, attach that entity as an object to your scene node. And then you can perform your operations, your three-dimensional geometric transformations, such as translating, positions, rotations, either with rotation or with yaw, pitch, and roll, and scaling of your node. And that effectively performs that operation on the node and everything that's inside of the node, which basically includes the objects that we attached to the scene nodes. So, so let's run this and take a look and see how the scene that we built, just kind of refresh our memory about how it looked like, and then we're going to perform a little build this a little bit more interestingly, and so that we would get a hierarchical structure. As the scene stands, we have three Sinbad meshes, and those are these green character in the middle. And then we have an ogre head mesh and a ninja mesh. And as this is standing, all these meshes are actually placed in a scene node. Each of the meshes is placed in its own scene node, and all of these scene nodes are attached to the root of our level. So basically, whenever I created the ninja node, I added this as a child of the root scene node. Then I created the ogre head node, and then I attached it as a child of the root scene node. Then I created the Sinbad node 1, and then I attached that as the root node, as another child for the root node. So basically what I created is effectively a star relationship. And so this is how my scene looks like. So this is my root node, and then all of these nodes are attached to it. So that's the ogre head here. Then one of the Sinbads, I placed the ninja node here, and then the other Sinbad here, and then I also have another Sinbad basically standing there. So obviously, I mean, if that were what I wanted to do, that would be a perfectly fine situation. But let's go ahead and redo this so that we would have some of these nodes re-parented to one another. So let's go ahead and do that in code. So what I'm going to do is I am going to go ahead and have these scene nodes actually created, and then the entities also created. So let's move all these scene nodes next to one another. Sinbad node 1 and Sinbad node 2. And Sinbad node 3. I'm not sure how many of these I'll use for this part, but let's see. So now that I have my scene nodes, let us go ahead and place one of the Sinbad nodes, for example, Sinbad node 1, and we're going to make that and route it to the or parent it to the root scene node. So that would be at the center of the place. Then let's also, for the sake of our view, we go ahead and comment everything out. So I have the Sinbad node parented to the root, and then we're going to go and attach and create the Sinbad entity. And then attach it to the Sinbad node 1. So again, the Sinbad node is Sinbad node 1, which is here. It is added as the child of the root, and then the entity, which is one of the Sinbad meshes, and I called it Sinbad01, it is going to be attached to, or as an object to the Sinbad node 1. So obviously you can expect when if I run this code, then the Sinbad node will be fairly small, or rather the Sinbad mesh will be fairly small and in the center of. Okay, so in order to see him, we actually would have to just drive in with the W key to be able to see it. Now, the node originally doesn't really have any kind of sizing or scaling. So it's basically the scale is 1. Its location, its position is at 0, 0, 0, the center of the world, which is where the root sin node is, and obviously its orientation is as it is. So in order for me to be able to see this Sinbad node, I'm just going to, again, just like what we did last time, we're going to just scale this up with 10 units and then compile and see what happens. So obviously you can see that this should sort of make the Sinbad node bigger. Okay, so now it's much bigger, so we don't really have to drive in. All right, fantastic. Now, let's go ahead and attach, or rather add, the Ninja node to the Sinbad node 1. So previously what I did, I effectively got the root sin node and added the Ninja node as a child to it. So what I'm going to do now this time is I'm going to go and say Sinbad node 1 and then add child. And you see the input argument would have to be an ogre node, which is what we already have, and so it would be a ninja node. Okay, so now if you want to think about it, the Sinbad node is parented to the root, and then I have the ninja node, another sin node, and I parent that to the Sinbad node, which is parented to the root node. So then now that I have this parent created, let's go ahead and create the ninja entity. And then I'm going to basically attach the ninja node, the ninja mesh, into the ninja node. So now if I compile and run, first of all, before I'll give you a few seconds while this thing is compiling for you to think about where do these meshes will be placed. Where would they show up? So think about it and then check to see if you got the answer right. Okay, so if your answer was that they both are placed at 0, 0, or rather the origin, your answer is correct. And the visual cue of it is basically what you see here. Obviously, you might have thought visually that the ninja and the Sinbad would be on top of each other. that would have been correct if the pivot points of these two meshes were kind of like at the pelvis or at the hip location, and they would have been placed there. But the pivot point for the Ninja is at the bottom of its feet, and then the pivot point for Sinbad, the mesh, is at its pelvis. And so obviously you can see that at 0, 0 location, which is the center of the screen, the Sinbad node is centered, so its pelvis is placed there, and then the Ninja is placed also at 0, 0, but the pivot of the Ninja is actually at the bottom of his feet, and so that's how they should look like in their place. Obviously, the Ninja is colossal with respect to the Sinbad, so let's scale him down. So we go and say Ninja node set scale, and I think we made him last time. I actually could have just copied and pasted this. Let's just do that. And now if we run this, their sizes, the size of the Ninja and the Sinbad mesh should be pretty much the same. Ninja's going to be probably still larger, but it should be fully in screen. Okay, looks pretty good. Well, actually, probably 0.5 was still too much. Let's make it 0.25. So I made this 0.25. All right. Oh goodness, the Ninja mesh is huge. Or maybe the Sinbad is too small. So let's just go ahead and make this guy much bigger. And let's make the Ninja even smaller. Okay, and now the size of these two meshes are comparable, and so just again, kind of as another cue as to how these are located. So the bottom of the feet is where Ninja's pivot is, and then almost the midsection is where the Sinbad's pivot is in terms of these two meshes. So when I attach them to the scene, that's how they are placed at the root scene node. So now this is the fun part. So the Ninja node is parented to the child. So I want the Ninja node to be placed behind Sinbad, kind of like sort of following him. So obviously, if you again think about the X, Y, and Z axes, the X-axis is the axis that points to the right. The Y-axis is the axis that points upwards. So if you place your thumb and your index finger in an L shape, basically, in front of you, the thumb is going to be your X-axis. The Y is going to be your index finger. And then the middle finger, if you just hold it so that it points to you, kind of like an axis shape, then the Z is going to be that axis. It's going to be the middle finger. So what we're going to do is we are going on the X, Y, and Z. We're going to move the Ninja outwards behind Sinbad. So that means that I would have to mess with its Z-axis or Z value. So I'm going to do Ninja node set position, and so vector 3, and then let's keep the Z at 0. So it's going to be still at the center of the screen. The Y also at 0, and then the Z, let's make that minus 100. So that would make the Ninja should make the Ninja go back in the screen behind Sinbad. I'll have to actually double check to see if my positive negatives are correct, but that's easy to check. We'll just run it and see how it looks. If Ninja came in front of the Sinbad, then that means that we would have to use the other sign. Yeah, apparently my axes were not quite right. And I think the Ninja... Oh yeah, the axes were right. So see, the Ninja is now all behind Sinbad. But obviously, it was covered. So that's why I didn't see him. All right, so since it is covered, I would like to see him. So that means that I can also probably put him about like 100 units or maybe 50 units to the right. So from my vantage point, from the camera view, I'll see Ninja behind. Okay, this looks good now. So the Ninja, you can see him, has kind of over the right shoulder, or rather the left shoulder of the Sinbad, and following. Although Sinbad is kind of like halfway down, so I want to bring the Ninja node down so that they are almost at the same location as well. So let's do that so that their midsections also match. I'm going to just copy this Ninja node position, and this time I'm just going to move the y-axis. Let's say negative, oh, I don't know, 50. Let's see if that is enough. Oh, that was way too much. All right, so we'll do negative 10. Obviously, you can automate this process. You can look at what's the size of your mesh and kind of get its pivot point and its bounds, and fix your position that way. Since we are playing and working with the set position, I think it would be a good experiment for us, an experience for us to go through movement X, Y, and Z. I think now we can safely assume that the midsection of the Ninja and Sinbad are almost at the same point. The problem is the feet are not matching up, and I want the feet to be on the ground, and so the Ninja is also still a little bit bigger. So what should we do? Oh, this is actually a good question for you. So should I want to make the size of Ninja and Sinbad the same. That being said, should I scale Sinbad up or should I scale the Ninja down? I'll let you think about it a little bit and maybe just go ahead and do it, and let's see what happens. I think this is a very good question for you to think about. If you want to actually wait for the answer, pause your video now. Otherwise, let's go and see. So let's first scale the Ninja node down a bit more. So maybe even half of what its scale currently is, which was 0.1. So we're going to make it 0.05. Okay, after I compiled it and ran, I noticed that I forgot to uncomment moving the Ninja down. So we shall do that. And let's see, setting the scale of the Ninja at 0.5, 0.5, 0.5 should give us almost the same size. Ninja and the Sinbad. What do you think? Do you think they are almost the same size? So if you think about it from the midsection of the Sinbad to where the head of the Ninja is, it's its size. And then, yeah, that should be fine. The Ninja could be a little bit taller than Sinbad. Then let's move actually the Ninja 50 units to the right so that they're kind of side by side, so I see them in the view together. Oh, 50 was too much. Why do I use these large numbers? Okay, yeah. So now they're kind of side by side, and yeah, I think their size should be all right. So then let's go also and move the Ninja 5 units downwards. And the feet are almost on the ground, which is fine. So that this works. I can be happy with this. And so now let's move the Ninja way back behind Sinbad, so that our Ninja sneakily follows the Sinbad around. And I'll tell you what I mean by following around. And you see here, the Ninja is now kind of right behind Sinbad. I'm going to make him go on the x-axis a little bit more to the right, so he's kind of looking over on the right shoulder of my Sinbad mesh. Okay. And go backwards kind of like 30 units. And I will be, I think, happy with this transformation. Okay, yeah. So the Ninja is right behind Sinbad and following. We don't really know if they're following yet, but we will see. Before I go to the next step, let's talk a little bit about the Ninja's rotation. The Ninja is kind of looking backwards. I want him to kind of look and follow the Sinbad. So obviously, if you think about it from what we saw last time, the way to make the Ninja to turn around is to use its rotation. And we know that we can use Ninja node to set its yaw, pitch, and roll. So which one of the three should we be doing? I would say that we should be using the yaw. Let's try that. Or rather, just yaw method. And then we will use the radians and math half. Should we do half pi or should we do pi? So half pi is 90 degrees. I want him to completely turn around, so that would be a pi. So that would be half pi times 2. Or actually, let's use degrees. And we make it 180 degrees. And so now the Ninja is actually looking where he should be looking. Okay. Now there's one problem. The camera is way too close to these characters, so that's one problem. And before I fix that, I asked you a question earlier. When I was scaling, should I have scaled Ninja down or should I have scaled the ogre up? The answer to this lies behind the hierarchical relationship between the Ninja node and the Sinbad node. So the Ninja node is now child or parented to the Sinbad node. So the Ninja node is the child of the Sinbad node. When I scaled the Ninja node down, then it basically takes the container of the Ninja and it scales that down. Let's see what happens if I scale the Sinbad node down. So Sinbad node 1, set scale. And let's make that at half. Okay, see, the problem is when I did that, when I set the scale of the Ninja and or rather the Sinbad at half, it scaled it, and also it scaled the when I scaled the Sinbad node at half, then it actually took the scale of the Sinbad and made it smaller, and also applied that to everything, that every other node and container that is attached to it as a child. So the transformations that you perform on one node, it propagates through all of its children. So the situation that I had earlier posed to you, that I had two meshes, the Sinbad mesh and the Ninja mesh, and the Ninja mesh was larger. And if they were independent in nodes, like the first time when each of them were just the children of the root, I could scale each of them independently and it wouldn't affect each other. But since now the Ninja is parented to the Sinbad, if I wanted to make the size of the two the same, I would have to change the size of the Ninja and make it smaller to match with the parent of it, which is Sinbad. If I made the size of the Sinbad change, then it would actually scale everything down. Also, what we tested out here is that, see, first I set scale the Sinbad node to 50. That made the Sinbad node bigger so that I could see it. And then when I set the scale at 0.5, remember, it's not relative. I reset the scale back to 0.5. So that made the Sinbad node much, much smaller. In fact, it just overrode the first scale of 50%. So by doing this successive scaling, when I scale up at 50 and then I scale down to 0.5, that doesn't mean 25. That means still 0.5. So the last operation will take over. So, so that was the answer to this question. Now let's set the scales back up to where they are. Now everything should look nice and clear as it was. So Sinbad is looking at us, Ninja is looking at it, and it's following behind. And so I said the camera was too close to the scene and everything, but I don't have a camera actor here to change and to work with. That's because the camera is set from my parent application, which is the example application. However, since I have my Sinbad node, I can move Sinbad node backwards so that it stays a little bit more farther away from the camera. And then since Ninja is parented to that, then it would be far away. So let's do that. So I do Sinbad node 1, set position, and then vector 3. And so I want it to go outwards, so I keep it at center, but at negative, let's say 100 points on the z-axis. And now if I run it, the two characters should be far away from me to see them. 100 may be too much, so I may actually move them a little bit closer, but we'll test that out in a bit. Okay, and this is how they look like. So let's move them a bit more then. Negative 500. All right, this is perfectly nice. So now you have the Sinbad and you have the Ninja, and they're all the way that we want them. And that's how we can actually go ahead and build our scene graph, basically drawing out the relationship between the actors that we have in the scene, and then when we draw that out and we think it through before we build our scene, then our lives would be much simpler. Then we can actually perform transformation to only the things that need to be relative to each other, the way that they have to be, depending on our application. So this is it. I think that this should be a nice and short video. I keep this these videos at chunk sizes, so you can kind of go back and forth between them. We'll leave this at here. In the next video, I will start talking to you about the different transformations in different spaces and what it means. And so we'll set up some transformations there, and then we'll program those so you get a good sense of and a good kind of taste of what scene graphs are and how you can actually perform the transformations in 3 different kinds of spaces: in world space, in parent space, and in local space. So I'll see you in the next video.